A car has an initial speed of 16 meters per second. It decelerates at 4 meters per second squared until it stops. What is the distance traveled? So it is given that the initial speed is u, 16, decelerates, so acceleration is negative, it's negative 4, until it stops, so final speed is 0, and we need distance. So what formula can be used? For example, v squared is u squared plus 2as, so it's 0, it's 16 squared, but since it's deceleration, it must be minus 2 times 4 and times s, and it becomes 16 squared, which is 16 times 16, over 2 times 4, or it's 8, and we can see that it cancels, so 2, so it's 32 meters. So it's C. The next. A block of mass 2 kilograms accelerates from a speed of 15 meters per second to a speed of 20 meters per second without changing its direction. What impulse acts on the block? First of all, what is impulse? By definition, it's force times time, and it is equal to change in momentum. mv after, or delta mv after minus mv before. And since m is constant, so it's mv final, or just v minus u. But it's very important, all values are vector quantities, so are vectors. So direction is essential, because, or actually, since it doesn't change its direction, change in momentum becomes, or it looks like this, that the initial is, for example, let's x be to the right, and the initial also be to the right, u, and v also to the right. So change in speed becomes just 20 minus 15. Or if you choose x to be to the left, so that you get negative 5 instead of plus 5, but by the magnitude it will be absolutely the same. So we get that it is equal to what, 5m, and m is 2, so it's 10 finally Newton seconds. And if it changes direction, so if initial is to the right and the final is to the left, so it becomes, and x is to the right. It's, for example, when ball is moving to the wall, so it's 15, 20, it becomes negative 20 minus 15, and by magnitude it becomes 35, not 5. Negative 35. Negative just indicates that f vector is in opposite to chosen x-axis, so force is to the left, and it's we consider a ball, so it's force applied on the ball, and it's definitely to the left, because force from the wall or by the wall on the ball must be applied to the left. Why? Because a wall must stop a ball and something like push it back to the left. It's very important when a ball rebounds at a wall, it's always plus by magnitude. Change in momentum, it's finally sum by magnitudes. But here it's finally 10, and change in momentum is the required impulse, which is force times delta t. And the next, A net force of 8 newtons accelerates a 4 kilogram body from rest to a speed of 5 meters per second. What is the work done by the force? First of all, there is no friction, and we can apply low conservation of energy, so work done will be what? Completely transferred into kinetic energy. There is no change in height, so no potential energy, so change in kinetic, work done, it will be transferred into not exactly kinetic, change in kinetic. So it means what? Kinetic, the final value minus kinetic, the initial value, and so it's mv squared over 2 minus mu squared over 2. Notice that it's change in kinetic, not m change in speed squared. It's never true actually. And since the initial speed is 0, work done is equal to the final kinetic energy, and it becomes what? 4/5 squared over 2, so it's 50 joules. Also, formula, basic formula that work is what? Force time distance, and in general cosine of the angle between the force and direction of motion, but definitely force is in direction of motion, so its cosine is 1, and force is constant, so it's 8 times distance, but there is acceleration, and force is ma, so 8 is ma, 4 times 8, so acceleration is 2, and from rest, so change, acceleration is change in speed, so it's 5 divided by time, but I need distance. Actually, we can calculate time and then distance, or we can just use another formula, so it's 2 times 2.5, and to find distance, what formula can be used? We can use s is what? U plus v divided by 2 times time, since time is already calculated, or also we can use what? S is ut plus 80 squared over 2, or we can use v squared is u squared plus 2a s. So for this formula it becomes what? 0 plus 5, it's 2.5 times 2.5, so it's 6.25. Let's check this using this formula. V squared, it's 25, is 0 plus, not plus, it becomes minus because it's deceleration, so negative 2 times 2 times s, so it becomes, you can see that s is what? 25 over 4, which is also 6.25. So distance is 6.25, and 6 times 8 it's 48, 0.14 times 8 it's what? 2, so finally it's 50. So you can see that we get the same result, so A is correct. The next, a person stands in an elevator lift. The total mass of a person and an elevator is 800 kilograms. The elevator accelerates upwards at 2 meters per second squared. What is the tension in the cable? So we can consider a person in the lift and the lift as one object, so that weight is 800 g and downwards, and there will be also tension upwards, and that's all. If we consider a person and an elevator as a single object, and it is moving with acceleration of 2 upwards, and let y direction be up, so the second Newton's law F net force is ma vector, and in projection or in components on y-axis it becomes what? Tension minus 800 G is 2 times 800, so tension is 800 G, which is 9.8 plus 2, and it is equal to what? It's approximately 12. 800 times 10, it's 8,000, and 0.2, 9.6 thousand, so it's D. It's D. The next. An object is released from rest in a vacuum at a height h above the Earth's surface. As the object falls, it passes a point of 0.75 h above the surface. What is the ratio kinetic energy of the object at height of 0.75 h and to gravitational potential energy of the object at height of h? And since it's in a vacuum, air resistance is negligible. So there is a height of h, and this question about what? Definitely about low conservation of energy, and at height h, and since it is dropped, so it has gravitational potential energy only, because the initial speed is 0, so it's mgh. And at some height, and this height is equal to 0.75 or 3/4 h, it has what? It has what? A gravitational potential energy, which is equal to mg 3/4 h, and plus kinetic energy. And definitely, since air resistance is negligible, total energy is conserved. So we can conclude that this kinetic energy is equal to what? 1/4 mgh. And hence the required ratio becomes kinetic at 0.75. It's 1/4 mgh. And gravitational potential at h is just mgh. So the required ratio is equal to 1/4. The next, a bird of weight W sits on a thin rope at its midpoint. The rope is almost horizontal and has negligible mass. The tension in the rope is. So let's consider a free body diagram. Definitely it must be symmetrical. So weight and tension in this direction, tension in this direction, and definitely it must be symmetrical, and let this angle be theta. And since this rope is almost horizontal, it means that the theta is near or tends to 90 degrees. So tension. And since it's in equilibrium, the net force or the resultant force is 0 in any direction, or net force, or all forces are balanced in all directions. Definitely, if we consider x-axis, you can see that t sine theta is equal to t sine theta, so it gets nothing. But let's consider vertical direction. Let's consider in projection on y-axis. So this situation looks like this, that t, or component of this t on y-axis, or projection of this vector on y-axis, it becomes what? T cosine of theta. But also this t on y-axis, it's also t cosine, so together it's 2t cosine theta. And minus w is equal to 0, or just is equal to W to be balanced by W, because these two forces are up and they are balanced by this force which is downwards. And what do we need? Tension. So we need tension. Tension is W over 2 cosine theta. But cosine is it's near 90, for example 85 degrees or something like that. And what is the value over cosine when it tends to 90? Unit circle, 0 degrees, 90 degrees, cosine it's what, x coordinate. So when theta tends to 90, cosine tends to 0. So it's very small value. For example, 0.01 or something like that. And it becomes W 2 times 0, 0, 0, 1 or something like that. And to divide by very small value, it becomes, for example, 1000 W or something, or 100 times W, or maybe million times W or something like that. So definitely it's not less than W over 2, not equal between, no, definitely it's greater than W. Or just cosine tends to 0, when denominator tends to 0, the result what tends to plus infinity, so it's very large value. And that's all for this question.